Let's suppose the Big Dog software sells computer components that cost $1,800 per system, but they turn around and are able to sell them for $2,700 each. Let's also suppose that our labor costs are $250 per system and overhead expenses are $10,500 per month. Let's first determine how many computers must be sold each month to break even, and then after that we'll try to determine the profit or loss for a month in which 20 computers are sold. Let's begin by building our total profit function. So we're going to look for our revenue. We're going to be selling our computer systems for $2,700 each, so let's represent that with 2,700 times X. Next, we want to start subtracting off our costs. Let's begin with our variable costs. We know that per system it's going to cost us $1,800. We also have some associated labor costs per system as well, so we're going to have to subtract off those costs of $250 per system. And then finally we have our fixed costs of $10,500. Collecting our like terms in X gives us a total profit function of 650X minus 10,500. Now we can calculate our break-even production level. Let's set our total profit function equal to 0, and then try to isolate X. We're first going to bring our fixed costs over to the left-hand side by adding. And then to solve for X, we can divide both sides by 650. Here we see that X is equal to about 16.15. So in order to break even, we're going to need to sell about 16 or 17 computers. Next, let's come back and answer the question about our profit or loss in a month where we actually sell 20 computers. Since 20 is bigger than our break-even point of 16.15, we do expect to see a little bit of profit here. So let's take our total profit function, which is 650x. We're going to replace x with 20, and then performing that multiplication and subtracting off our fixed costs gives us a profit in that particular week of $2,500.